So today in class we started talking about like terms, and once we start looking at like terms, what we've been looking at is multi-step expressions. So for us at this point, multi-step expressions, we've already looked at our order of operations and done some expressions with just numbers. But now we need to start looking at these multi-step expressions containing variables. So for the next couple days, we're going to focus on these kind of variable expressions. Now, what we want to spend our time today dealing with is simply just what we like to refer to as like terms. And so again, if we're going to refer to these as like terms, all right, this word like is referencing that they have something in common. So we're looking for terms that have stuff in common. So for this particular setup, we would say that these two terms are like terms because what they have in common is that they both have the same variable, x. And we can go ahead and pull those, and we can go ahead and work that little teeny expression out. 4x's take away 3x's, that leaves us with 1x. Likewise, we can do the same thing with these two terms. We could reference these as like terms because what they have in common would be the variable y. So we can pull those. What's important to notice, operations, okay? The operations are attached to the term that is directly after them. So wherever this 2y goes, this plus sign goes with it. Wherever this 3x goes, this minus sign goes with it, and so on. Now when we get to this point, normally, we don't normally put a little plus sign in front of something if there's nothing else. So it's not necessary, but we do need to be aware of the fact that we can use it. 3y's plus 2y's, that is equal to 5y's. We move that plus sign to the center. 1x plus 5y. All right, these would not be considered like terms because this group has different variable than what this does. All right, so we would say at this point, this problem is what I like to refer to as ASAP, as simple as possible. Which basically just means we have taken this expression, we have condensed it as much as we could, and now we have to stop. All right, as I tell the kids in class, we have no more superpowers left to be able to do anything with this problem. So even though it's incomplete, it's actually we've done as much as we can do by our standards, and so now we need to just put it to rest and be done with it. Okay? So I want to just quickly look at a second example here. 4y minus y plus 3x plus x. So I want to make sure I discuss this scenario here because we run into this quite often. Again, we're looking to just group our like terms together, and so by our prior example, and I've condensed this a little bit to make it go a little faster for you. All right, obviously these are all like terms because they have the same variable in common. And the issue we run into is 4y minus y minus y. Well, what exactly does this represent right here? And likewise over here, what exactly will this x represent? And so what we have to, just to make a long story short, we do have to acknowledge that each of these counts as a single. We do not put the number 1 there because, again, that basically is telling us to multiply by 1. Well, what's 1 times y? That would be just represented with y. So that 1 is still a part of it, but we normally do not write this just simply to save on all of the stuff we have you write anyway. So this counts as 4y, take away a single, take away another single. So grouping, we would end up with 2y's. 3x plus another single would get us to 4x. And that's, again, we would not be able to go any farther. Different variables, we want to keep those separate. So our like terms, this is all we can do at this point. So we would stop here. Your homework assignment is on formative this evening, so good luck with that, and we'll hopefully be able to wrap that up tomorrow. Have a good night.